Hey everybody, it's Miss Berry. In today's video, we're going to be going over section 8.2, which is called the student's T distribution. If you plan to take another stats class, like if you're environmental science major or biology major or psychology or sociology, or nursing, and or maybe you're going on to graduate school and you're going to take another stats class, then you will definitely be using the student's T distribution. It's a very commonly used distribution in statistics. All right, so in the last section, we did examples where we were finding confidence intervals for a set of data um, where we knew the population standard deviation, but in real life, this is pretty rare. We often do not know the population standard deviation. So the student's T distribution is the distribution that's going to allow us to estimate the population mean and construct those confidence intervals. And later on, we'll use the student's T distribution to perform hypothesis tests. So we're using this student's T distribution to perform inferential statistics when the population standard deviation is unknown. All right, so the keywords that you're going to be looking out for in the confidence interval problems and in the hypothesis test problems later on is whenever you're reading the problem, you want to keep an eye out for the words population standard deviation. If you see the words population standard deviation, then you are going to be using the normal distribution. If you do not see the words population standard deviation, if you see something like the sample standard deviation, then you know that you're going to be using the student's T distribution. All right, so here's a little breakdown of when are we allowed to use the student's T distribution. And it says if our population is normally distributed, so if you have some background knowledge about the what we call the sampling distribution of the variable, and you know that that's normally distributed, then you're allowed to use the student's T distribution. This would be a scenario where maybe you know that your variable comes from a normal distribution, but you have a really small sample size. So maybe you're working on some type of rare species of animal or some doing research on a rare disease, and you have a very small sample size to choose from, but you know that it comes from a normal distribution. Then you can use the student's T distribution. And then the second scenario where you're going to be allowed to use the student's T distribution is going to be when your sample size is what we call sufficiently large. And in general, we say that sufficiently large is going to mean 30 people or more being included in your sample. So your sample size being 30 or more. Um, so in both of those scenarios, if you have a small sample size, but you know that your population comes from a normal distribution, or if you have a sufficiently large sample, which we call n equals 30 or greater, then we're allowed to use the student's T distribution to estimate those population parameters. All right, so here's a picture of the student's T distribution. In red, you've got the standard normal distribution. And then in green and blue, you've got some examples of the student's T distribution. The student's T distribution is going to, the shape of it is going to vary based on what we call its degrees of freedom. And the degrees of freedom is just equal to the sample size minus 1. Right, and so before I get into degrees of freedom, I just want you to compare the standard normal distribution with the student's T distribution. You can see that the student's T distribution is a little bit more of a conservative estimate compared to the standard normal distribution. The tails are weighted a little bit heavier. So you're seeing the tails are up a little bit higher than the normal distribution. And you can see that our peak is a little bit lower. So that probability in the middle is a little bit lower. We know the height of the curve corresponds to the probability. And the way that the student's T distribution works is the larger your sample size, so as you increase this value for your sample size, the student's t-distribution is going to get closer and closer and closer to the standard normal curve. Right, so if you have a super big sample, think like 100, 1,000, 500, something a really big sample size, then you're going to get really close to the standard normal distribution. And it says the exact shape of the student's t-distribution is going to be determined by its degrees of freedom, which are really easy to calculate. It's just the sample size minus 1. All right, and if you want to if you want some more information about why is the formula for the degrees of freedom equal to n minus 1, I'll put up a little video about that. If you want to just not worry about that, that's okay too. All right, so let's talk about some properties of the student's t-distribution. I'm just picking 4 properties to talk about here, but there are many properties of the student's t-distribution. If you wanted to study it more closely, you could. All right, so our first property says the t-distribution is symmetric and bell-shaped, and it's centered around the critical t-value t equals 0. All right, so this is the mean of our student's t-distribution, t equals 0. Notice that we're using the variable t when we're working with this normal distribution. If we're working with the standard normal distribution, then we use the variable z. If we're doing just any other normal distribution problem, we have just been using the variable x. Right, so t-distribution, symmetric, bell-shaped, centered at 0. So that mean t equals 0 is in the middle. Right, the next property of the student's t-distribution is that the exact shape, so exactly how tall is the peak, exactly how high are the tails, is completely determined by its degrees of freedom. And we just learned that our formula for degrees of freedom is just the sample size minus 1. Right, so really easy. All right, just like the standard normal distribution and the normal distribution problems, the total area under the curve is equal to 1. This is a very useful property for us. And then our last little property that I'm including here, the larger the sample size, the closer the t-distribution gets to the normal distribution. So we talked about that. And specifically, it's getting closer and closer to the standard, getting closer and closer to the standard normal distribution, since that value in the middle is 0, just like the standard normal distribution. All right, so here are some examples. We're going to do all of these examples without our calculator, and then in the next section, in 8.3, I'll show you how you can use the calculator to get these answers. Now, some of your calculators will not be able to do these problems, which is why I'm showing you how to do it by hand first. All right, so it says consider the value of t such that 0.05 of the area under the curve is to the right of t. All right, so let's read that again. Consider the value of t. All right, so we're talking about the t value, that's the value on our number line down here. The value of t such that the area under the curve is 0.05 and it's to the right of t. All right, so this is the only one where the area to the right is shaded, so that's definitely our graph. We can see that our t value, we call this a critical t value. This critical t value is to the right of 0, which would indicate to me that t here is positive. Our critical t value is positive. All right, so t is to the right of 0. So t must be positive. All right, that's going to be important. So making that decision whether t is going to be positive or negative is going to be important. So that's always how I would suggest starting off the problem, would be to consider what that graph would look like and then decide from there whether you would have a critical t value that's positive or negative. Okay, so it says consider the value of t, or excuse me, sorry, same thing as before. Consider the value of t such that 0.05 of the area is to the right of t. This time they're asking us, assuming that the degrees of freedom is 14, find the t value from the table. All right, so the table that it's talking about is this critical t table. That's in D2L, so make sure that you if you need to, go ahead and pause the video right now and then go download that table. This table will be available to you on the exam. There'll be a link that you're able to click, and it'll pull up the critical T table. But you can also print it out. So if you have a printer or if you want to run to the library and print it out, you can absolutely do that. So I have a little, all right, so I have a zoomed in version of this table here. And it says, again, assuming that the degrees of freedom is 14, find the T value from the table. All right, so here on the left column, you've got DF, that's the degrees of freedom. Up here in the top of our table, it says area in one tail, area in two tails. So you're going to decide, okay, am I looking at area in just one tail or am I looking at area in two tails? In this example, we were just looking at the area to the right of T. So that would be one tail. And it was 0.05 if I remember correctly. I've accidentally cut it off up there. But yeah, it looks like it was 0.05. And then we'll go down here to 14 for our degrees of freedom and highlight that. So now you're just going to look at the intersection of that column and that row. I've went ahead and highlighted it here so you can easily see that intersection. All right, so there's our intersection point, and that's our critical T value. So it's T equals 1.761. And again, we had already previously determined that that was going to be positive based on the fact that the area was 0.05 to the right of T. All right, let's look at another example. All right, so this one says, consider the value of T such that 0.01, very small, 0.01 of the area under the curve is to the left of T. All right, so we've got an area on the left problem. There's an area on the left. All right, so that's definitely our graph. Notice that this time, since T is to the left of 0, that's going to indicate to me that T is going to be negative. All right, so we're going to have a negative critical T value. And again, that's all because, sorry, let me try that again. All of that was because T is to the left of 0. Okay. All right, so we're going to have a negative critical T value since T was to the left. Our T value here was to the left of 0 on our number line. All right, so again, 0.01, area is to the left, and degrees of freedom is 28 this time. All right, so let's pull up our table. You can see I've just, I kind of went in and like cut and pasted this together. So we're seeing the top portion of the, sorry, you couldn't see that. We're seeing the top portion of the table and then the bottom portion of the table. So this time we are still looking in one tail. We're just looking at the area under the curve to the left. So that's one tail and it's 0.01. Be careful with these. There's also a 0.1 option. So just be careful not to get those mixed up. And degrees of freedom is 28. So let's highlight 28. And then we're going to find the intersection of that column and that row. And we had already decided that this was going to be a negative critical T value. There we go. All right, so there's our intersection. And we had already decided this was going to be negative. So this is going to be a critical T value of negative 2.467. Negative 2.467. Now we're going to be using this number for something later on, but for right now, we're just practicing using the table to find the number. All right, so now we're going to get into some problems where you don't have to identify the graph. We're just going to draw the picture of the graph ourselves. It says, find the value of T for a T distribution that has 23 degrees of freedom, and the area to the left of T is 0.025. All right, so we're going to draw our little picture of our t distribution. The area to the left of t is 0.025, so that's definitely going to be on the left-hand side of 0. And that tells us that our t value is negative. All right, so that's 0.025, that little shaded area. So our t value is negative. Now I'm going to pull up our critical t table. All right, so we're looking at area in one tail is 0.025. That's right there in the middle. All right, so let's highlight that. And then 23 degrees of freedom, so we'll go down and highlight 23. And then we'll find the intersection of that column and that row. And we see that that critical t value is going to be negative, so it's negative 2.069. Negative 2.069. All right. I would like you to, well, actually, this is a different one. This is going to be area and two-tailed. So I was going to tell you to pause the video and try this one on your own, but let's do this one together since we haven't done a two-tailed one yet. All right, so it says find the value of t for a t distribution with 40 degrees of freedom such that the area to the left of negative t plus the area to the right of t equals 0.02. All right, so we've got a t distribution, putting the mean in the middle, and then we're looking at two critical t values this time, negative t and positive t. And now I'm going to pull up my critical t table. All right, and then you can see once again I have just sort of cut this and pasted it together. I'm looking at the area in two tails this time, so I'm looking at this portion in the top, and the area in two tails is 0.02. There's 0.2 right there. Here's 0.02. So I'm going to highlight 0.02, and then I'm going to highlight 40 degrees of freedom over here. Sorry, my computer's not cooperating. There we go. And then we're going to highlight that column and that row and find the intersection. All right, so there's where they cross, 2.423. I have a critical t value on either side, so I have two critical t values this time, negative 2.423 and then positive 2.423, excuse me. All right, so negative and positive versions of that same number. All right, then we have just a slightly different version of this problem. Find the value of t for a t distribution with 16 degrees of freedom such that the area between negative t and t equals 80%. So this time it's telling you the opposite. So it's telling you that the area in between those two critical values is 0.80 or 80%. All right, since we know that the total area under the curve is 1, that means that the shaded area plus this unshaded area must be 1. So that's 1 minus 0.80, which is 0.20, which is going to be in the tails. All right, so let's pull up our table. We're looking at the area in two tails as 0.2. So that's over here. Remember, again, be careful not to mix those two up. This one's 0.2, this one's 0.02. All right, so I'm going to highlight that, 0.2. Then I'm going to highlight my degrees of freedom is 16, so down here. And then I'm going to do the intersection of that column and that row. All right, that one was easy since it's just right next to the 16. We can see that that critical t value is 1.337. And again, we have two critical t values this time since we are looking at the area in the tails. So that's going to be negative 1.337 and then positive 1.337. All right, and then our last problem, find the critical t value for a 90% confidence interval using the t distribution with 19 degrees of freedom. All right, so very similar to the last problem. A confidence interval is always going to be the middle 90% or 95% or whatever you're looking at, whatever your percentage is. So we're going to put 90% right there in the middle, or 0.90. All right, so since the area in the under the curve has to add to 1. We know that there's going to be 0.10 in the tails. All right, so we'll pull up our little table. We're looking at the area, and 2 tails is 0.1. Over here is 0.01. Here's 0.1. All right, so highlight that column and that row like we've been doing. 19 degrees of freedom is down here at the bottom. All right, and there's our intersection of that row and that column. All right, so again, 2 critical T values, so negative 1.729 and positive 1.729. Okay, so now I hope you have a good grasp on how to use the critical T table. Again, that'll be linked in the exam for you. And we're going to talk about what are we going to be using this number for in the next section. So stay tuned for that. All right, let me know if you have any questions. I'll see you guys next time.